Hi everyone, welcome to another Tiny Experiments. So this is an interesting thing I've been playing around with recently, and it really just something I've been playing around in the last week. So both of the code examples here that I'm going to put on GitHub and include a link in my description are very early days, but I thought I'd just share it now so people can play around with some of these ideas. And I'm just going to see where I'm going to go with this, but this might be the only video I do about this. So let me sort of unpack this. So underneath this all, as it says in the title, this is really about an experiment with A/B testing of both models and instructions. And I've done this in a couple of different ways, and we'll look at the two different pieces of code I've got here. But on top of that, the icing on all of that is this particular one was exploring something seemingly unrelated in some way. So as probably long-term viewers of the channel know, is I'm very interested in meditation and gnosis and all sorts of things to do with contemplation. And I had a very interesting experience recently when I was I'd sort of entered a state of quite exquisite and very pleasant silence almost. It was. I haven't had that in a long while. But what was really interesting is that just after that, all of these almost seemingly unconscious and random thoughts, snippets just bounced out of nowhere. Now, they weren't about a memory or anything. They were just random things. And I'm, obviously used to, through meditation, going to meditation as a way of, dealing with monkey mind, sort of everyday background chatter. But it's been a while since I've experienced that sort of almost like storm after the calm thing. And so I sort of did a bit of investigating and thought, I'm not quite as up to speed on some of the methods of dealing with whatever sort of bubbles up after meditation that as I used to be, apart from just basically just sitting with it. Which is the way that I usually, deal with that, and that's how I dealt with it with this particular incident. I just sat with it, and watched it, became mindful of it. But I thought, there must be out there some relatively new techniques, and I through actually, funny enough, through brainstorming with an LLM online. I can't remember which one it was. It was probably Gemini, but it could have equally been Copilot or Claude. Through their sort of free tier, I was just sort of poking around, and this term RAIN, for Recognize, Allow, Investigate, Nurture, came up. I'll include some links in the description to stuff that you might find useful, see if I can find anything, because I really found most of it through just kicking the tires in an LLM and spinning out some of the stuff. And what happened was, simultaneous to that, I was working on finding uses for smaller models in Ollama. I don't know if anybody's played around with the small models, but you often reach a point with them where you go, okay, I'm not quite sure how I'm used to use some of these sort of quite tiny models, because they tend to hallucinate, particularly when you're doing them inside an environment like Ollama and you're not doing any tool requests, you're not doing any search grounding, that sort of thing. So there's no link to the outside world. It's all just happening inside of the LLM, which I find really interesting. And some of the things I find most interesting is the sort of emergent properties you get when you're pushing the limits of the LLM. So what I did was I just came up with a list of basically some models on Ollama that were around about 3 billion parameters. So we got 5.3 mini, Llama 3.2, Mini, because there's a couple of different versions of these. We've got the Gwen 2.5 3 billion parameter one. I also dug out Llama 3.2, the 1 billion parameter one, and then some of the really tiny Gwen 2.5 stuff, so the 1.5 and the 0.5. So the point is, there's nothing here. I mean, this is in terms of parameters, this is the biggest model, the Phi 3. So I thought, yeah, I want to iterate through those. I want to iterate something through those. Now, I wanted it so I could put the user, just any text in there, like anything, like from, how do I code in Python to various other things, because I wanted to push the limits of the LLM. But I wanted to also iterate through systems instructions based around predominantly aspects of RAIN initially, but then it got spun out as I brainstormed it into RAIN, mindfulness adjacent things. So we have these number of different system instructions that are going to be iteratively loaded up, and we've got a neutral one there, and then there's these other ones here. We've then got some sampling parameters, very straightforward. You could change those to whatever you like, 0.7, 0.9, top K is 50. That could be, say, I don't know, on this, with this particular models, it could be what the optimum one could be. You could decide not to set it at all, actually. I mean, for all of this, you could just decide not to set any parameters, but I fancied setting some parameters and leaving them locked. We've got the base URL, the endpoint for the base URL. Obviously, I'm running Llama locally. I wanted to use a timestamp, so I could timestamp the file name, and also, use that within the MD file. As always, keep things fairly simple. I'm generating an MD file because this is producing unique files for each experiment, if you like. I've got it in write mode because every time you run this, it sort of generates a new file because it's date stamped by date and time. So we've got some markdown logging, just what we're doing, what the prompt was when it was generated, and then we're iterating on the outer part. So what we're doing is we're iterating through the models, okay, one by one. So Phi 3, you can see all that, and then we're iterating. So we're doing all the combinations basically of the models and the system instructions, and we're able to do that in a single, like a for loop here. And then for each combination of those, we are pushing the payload into Ollama for the particular model in question. So just to recap, our prompt, whatever we put in, stays the same, but we get all the different combinations of models and system instructions, but our generation parameters for everything stays the same as well. And again, you could play around with these. You could have an incrementing generation parameters. Once you realize how this works, you can hack it up. The code's pretty straightforward. There's obviously a few things in here which are idiomatic of Python, but generally I haven't gone down and done anything that's sort of idiomatic specifically to, say, object-oriented programming. The next example, that's more the case. So this was really early days, and it is just very procedural, top to bottom. There's no main in here. We're running it very script-like. So the only complicated bit is really happening inside of here when we're doing the markdown logging. That's when we're doing the requests and getting the stuff back. and just basically writing it to the file. So we've got the model, the system instruction, instruction test, the response, the markdown, the answer, and we're encasing all of the answers in markdown markers in there, so they're easy to pick out. Now I'm not going to run this now, apart from just show you what happens when you fire it up, but I've got something I prepared earlier. So we just type in what we want to prompt. Now what I've done, this isn't a dictionary, but these are in comments. I've put some prompts to try, which are more to do with sort of dealing with emotions or physical manifestations or stuff you're trying to work through. But equally, because of just the way this is and it's open, you could put anything in there. So you could put, how do I create a function in Python to produce factorial, something like that, and just see what happens because that always fascinates me. I haven't done it yet. Now, other word of warning, this takes quite a while to run. So I think when I first ran this, I just left it overnight. It doesn't take overnight to run, but it can take like a while, because it's got to increment through the models and increment through the system instructions. And when you do all of that, this is what you end up with. So you can see here, got quite a large file, and you can see how it's sort of split up. So we've got the first bit there, and then it actually, so here's the prompt. That's the one I chose, sense of dread. And then it just goes through, and for each model, so it's going through, so the model, it then iterates through the system instructions. So we get agnostic baseline, gentle coach, curious inquirer, and so on and so forth. Now you'll notice the way the models are organized, they're roughly running from biggest to smallest in terms of parameters, billion parameters. So we go from 5.3, and again this is just raw responses, so we're going to get any of these little things that the LLM is pushing out as part of the raw response. Yeah, I would say the raw response, this is the raw part of so it's not the whole raw JSON response, but it is the text element from there without any other shenanigans doing on it. We're not doing any what do they call it? I'm trying to think of the term now, but we're not doing any stripping, anything like that. We are just literally encasing this in a markdown, whatever you call that. I'm struggling for terminology here, actually. It'll probably come back to me after I've finished the video, and I'll be kicking myself. So then we move on to, you can see here, this would be, so there's 5 mini, the last one, and then we're now moving on to the Llama 3.2 mini, but going through the same things. So it's pretty interesting, after the fact you can go through and you can see, okay, when I use this model with this particular thing, I got this response back, and then you can cross compare it against other models. Now, of course, what you could do is reorganize this to better suit, comparing. So at the moment, what it's doing is it's more A/Bing the system instruction, which was originally where I'd gone, but then in parallel with that, because I was working on trying to find a use for small models, that's where that came in. So that's why I've chosen to do it this way around, with all of the same model with the different system instructions, and then moving through. So that way, what I wanted to see is when I got to the really small 0.5 malarkey shenanigans, how much it would start to fall apart, if at all. Because that was part of my curiosity, was that for stuff like this, where you're helping it quite a bit in terms of, You know, we've given it what rain means, so it doesn't have to work out any of that. Yeah, where it would go with this. So you can see we've got 0.5 agnostic baseline, gentle coach, curious inquirer, guided meditation voice, inquiry coach, and so on. So as I've said, you can play around with this with just some of the ideas up here. You know, they're just there as prompts. They're not in a dictionary at the moment. And, you know, how I just do it is basically I pick one, copy, paste it and run it and stick it in here. So, you know, if I wanted to pick, say, I keep replaying a mistake I made last week. How do I like this feeling without getting stuck into it? So if I take that one, okay, as my thing. And again, you can make this a lot cleaner, but this is just really early days with this experiment. I had to squeeze this in as part of some other stuff I was doing this week. So we do that, and then it literally goes through. Now it feeds back to the screen to tell you where it is in the grand scheme of things. You can see it's already created the MD file there at the start, and it will just keep packing the results into that MD file as it goes along. So I'm using Visual Studio Code, so I can actually see in Visual Studio Code it's sort of building that up in real time. Now at the moment there's nothing there, and because I'm saving this onto the cloud, there could be a bit of a lag, but you'll see in a moment it'll start to work its way through the different system instructions. So it starts off with agnostic baseline, then it moves on to whatever was next on the list, which is gentle coach. And the cool thing with this experiment is, of course, you can add in, it'll just run through however many things you've got in the systems instruction dictionary, or however models it'll run it through. Of course, you do have to make sure you've downloaded to Ollama, you've pulled to Ollama the models you want to use. And I will include links about, how you set up Ollama as always, and links to Python and anything in here which requires a setup. But you can watch previous videos where I've gone through and talked about setting up Ollama on a system, those sort of things. So I'm not going to repeat it here. So that's the first one, and you can see, it's moved on there. We'll just leave that chugging away in the background there. So the other one was this. So following on from that, and this is something I actually put together, was it today or yesterday? I can't remember exactly. And this one leans a bit more into object-oriented stuff. It's a bit more idiomatic of that particular aspect of, the many paradigms you could pull off in Python. And also you can see it's got the usual sort of main shenanigans going on here. So it's a bit further down the line. And this one, what's interesting about this is takes a slightly different approach. It is another sort of way of doing comparison testing. But what we're doing here is again, it's a small model versus slightly larger model evaluation. But I'm keeping it within the same type of model. So this is Gwen 2.5, and it's 0.5, which is the small one, the smallest one for that. And then the one that I would usually run, which is a 7 billion parameters one, which is probably, I can run that smaller of the two OpenAI open weights model on this machine, just about, with 16 gig of RAM on here. But I have, 7 billion parameter models run okay. They don't run fast, but they run okay, and I haven't any trouble. Anything bigger than that, I certainly wouldn't be able to go up to, I think 13. I think isn't the one from OpenAI, the smaller one, is 10 billion. Yeah, something like that anyway. I had an instance the other day where it just couldn't quite find enough memory, but it's because I was running Google with about 12 tabs open or something stupid. So you can see here we've got a number of class definitions. It's sort of config, so to do with configuration. So the alarm model A, the B, the API key, which I'm grabbing from my environment, And again, you would need, obviously, for this particular experiment, unlike the last one, we are using Google Gemini here to act as like an arbitrator, because I thought it'd be interesting to compare small with sort of medium, and then get the Google Gemini 2.5 Flash from the web, acting as an arbitrator, sort of evaluating the two models against each other. And then we've got for some various functions here which are going to get our Ollama response, access Gemini, and have this quite elaborate prompt where you've got the original task and then the response from model A and the response from model B, and some evaluation questions there and some scoring. As I didn't mention this necessarily in the previous one, but as with a lot of these, very minimal error checking. I mean, it'll catch it, but you'll just get an error. It's not going to dispatch different error catching based on different types of errors. That's what I'm getting at. Then we've got the report generator class. So initializing the report, logging the test results. And then we have the main section. So we've got our test panel. So for this particular experiment, what we're doing is we're running through a number of very simple prompts. These are really simple prompts, the sort of things that tend to come up when you're testing, I tend to use when I'm testing LLMs. So, write a story, explain something quite advanced, draft an email, do a recipe, translate, do a plot to something or explain a book, do some beneficial thing, what's the benefit of X, what are the Y benefits of X sort of thing, write a Python function, do a poem, and then do some sort of riddle. I haven't got things like mathematical problems here, but you could add those in. Again, you can extend these. So this test panel, you just keep adding to this list. Then we've got down here, we've got the bit that retrieves the bit that checks to make sure we actually retrieve the Gemini key, just in case there isn't one there. And then stuff to basically run the appropriate parts, appropriate functions in their classes there. And then we just print the results to the screen. So A, B, the Gemini assessments, you can see as it goes along, logs everything to the report generator, and then it just waits a certain amount of time before the next test. And then you get this A/B test completed. So again, it's looping through these test tasks for the models A, B, and then using Google Gemini to compare. Now, one thing to notice here, although by default when you access Gemini 2.5 Flash, thinking is on, so for this particular model, thinking will be on, there's no search grounding going on here. So it's not getting any help. It's not getting any help from the internet. But you could do that. You could add in within, where is it? The Gemini requests. You could alter that to basically introduce Google grounding if you wanted to do it. I decided I didn't want to do it for this. I was quite happy with the way it turns out. You can see we've got a number of things we're importing here, including the Google generative AI library to do this. So again, a number of precursors here, but if you've been following through this series and watched a lot of the ones I've been doing on LLMs and using Ollama and Gemini, you've seen what sort of environment you will need to set up to do this. So let's just run this and show you the sort of early parts. So with this one, if you run it, you'll see as it goes through, there isn't anything to enter. It is just working through these these prompts. The other thing you'll notice is I'm not explicitly, I don't remember doing this here. Trouble was I was working on several different things at once, as I tend to do. There is no explicit setting of system instructions. Now, one thing, if you've worked in Gemini and Ollama, the way you set systems instructions are slightly different for with those with the platforms. But for this one, I opted to just leave it what it. Yeah, so I had a bit of a glitch there when I was recording. I think it must be I'm really sort of pushing the system here. I've got multiple Python things running to LLMs. So I'll start to wrap this up. So hopefully you'll find this useful. I will upload this to my GitHub page and include links in the description. I don't think there's anything else I need to add to this. But as I've said, with this, both of these will take quite a while to run. Unless you've got like some super duper machine that you're running Ollama on. So we're now onto the quantum entanglement question. The other thing is, as this goes along, it does just feed back to the screen or print to the screen the sort of thing that is coming off. As you can see, there's also a waits 5 seconds between doing the next one. You probably don't need that. There's not enough. Google Gemini is not being requested fast enough for it to. Or this model isn't being requested fast enough, even on the free tier, to sort of exceed the per minute thing. But I've started adding those in recently because I have run into problems where I was getting issues with me trying to issue too many requests in one go, particularly when I was doing iterations for tests with just using Google Gemini, or if I was playing around with something that is capable of concurrency out of the box. So if I'm messing around with like Erlang, stuff like that. Anyway, thanks once again for watching. Bye for now, and I will catch you in a future video.